Hello, welcome back. This is Calc 1 by Dr. Oz. Today we're going to go over a brand new section called Integration by Substitution. And this is the first video in a series of three. And we have 5 course learning objectives to achieve. In the first video, in this one, we're going to focus more on the pattern recognition to find an indefinite integral. And in the next video, we're going to cover these 2 learning objectives. We're going to learn how to change variables to rewrite an indefinite integral, and we're going to derive generalized power rule for integration to find an indefinite integral. Once we gain those skills in the third video, we're going to sort of like mimic the same type of techniques for evaluating definite integrals, and eventually for special functions like even or odd functions, we're going to learn how to quickly integrate using the properties of integration. All right, let's start. All right, in this section, we're going to try to integrate composite functions. We have in fact 2 different techniques that we're going to touch. In the first video, we're going to focus more on the pattern recognition. And when I say pattern recognition, we're talking about substitution, what we're going to call U substitution mentally. In the next video, you're going to see that we're going to do change of variables to rewrite the integral expressions. So here, the role of the substitution is similar to what we did in the chain rule for differentiation. So we're sort of like undoing the chain rule. Remember that differentiation and integration are 2 opposite operations. So chain rule and differentiation corresponds to U substitution or pattern recognition and integration. So let's hit the road. All right, here is the chain rule provided for us. So let's say like we have a composite function, let's say like y equals f of u and u equals g of x. So we're talking about y equals f of g of x. So this is the composition of capital F and g functions. And if you would like to use a chain rule to take the derivative of this composite function, you see that we derived it as the derivative of the outer function, which is f prime of g of x, times the derivative of the inner function, which is g prime of x. So this was the chain rule that we practiced in the previous chapter when we talked about differentiation rules. So now we're trying to integrate this part. So we're going backwards. So we took the derivative. So now we're looking at the antiderivative. And for now, we're just considering the indefinite integration. So we don't have any limits here. So here we go. So I'm trying to integrate this function. And we just showed by the chain rule that the antiderivative should be f of g of x, because that has the derivative f prime of g times g prime of x dx. So after the integration, you should get back to where you start. So f of g of x plus the integrating constant. So this is, again, essentially we're using the chain rule. First here, we use the chain rule so that we had this pattern here, f prime of g of x multiplying g prime of x. And if you integrate that, you have f of g of x. So we're going to look for the pattern that, you have some kind of like an inner function coming along with its derivative outside. So here we go. It's now good to state what we mean by pattern recognition now. All right, this slide talks about the anti-differentiation of a composite function, but for the pattern recognition, we should probably focus more on this equation here. So we have f of g of x multiplying g prime of x integrated. So you have the inner function, an outer function, or inside function, an outside function. So when you take the when you take the integral of that, then this is equal to f of g of x. And who is f again? F is an antiderivative of little f. So if you know the antiderivative, and if you follow this pattern here, that this composite function multiplying the derivative of the inner function. So that means this is your pattern, and all you need to do is to find capital F, the antiderivative of f, and then the result is going to be this composite function f of g of x plus c. So going back to the actual result here. So if you have two functions, g and f, and if you're trying to integrate f of g of x multiplying g prime of x dx, and the result is f of g of x, as I just mentioned. Here, the relationship between capital F and little f is when you take the derivative of f, capital F, you should get down to little f. Okay, so this is one formula. And I also mentioned that you can use a change of variable. You can define another function, auxiliary function, we call it like u. So you can make this like change of variable. So when you say u equals g of x, we'll look at the differential here, differential of u, to be like g prime dx, right? G prime of x dx. Here we go. I can rewrite this integral as f of u times du with this new variable. And if I know the antiderivative of little f, let's say I know capital F, so the result is going to be capital F of u plus c. And after the integration, you should go back to the original variable, which is x. Okay, so u here is an auxiliary variable, and once we're done with the integration, so we go back and we write it as like f of g of x plus c. Okay, so I think this way of rewriting the integral is going to be used a lot in this chapter, more than this one. Pattern recognition is something that you do it mentally if you're like really good at integrating composite functions. This is a one-step approach, right? In one step, you can get down to the conclusion. But if the given integration is too complicated, then you use the u substitution. So you change the variable, you come up with this auxiliary variable u, and convert this integral here into the u version of that. So this is like here the integration variable is x. Now we have the integration variable u. But this way, by knowing an antiderivative of little f, you can actually write down the result of the integral in one shot. All right, let's go through this example just to recognize the f of g of x, g prime of x pattern. Here we go. So remember that this part should be f of g of x based on what's given in the question. And this part looks like it's g prime of x. So I think the natural question is to ask, like, who is g if g prime is 2x? Well, g prime of x could be x squared, but look, inside you have x squared plus 1, and this is f of g of x. So it's wise to take g of x, x squared plus 1. I still have g prime of x equals 2x, obviously. And apparently f of g of x then should be x squared plus 1 squared, very well matching with this pattern here. And that's in fact equal to f of x squared plus 1 equals x squared plus 1 quantity squared. So you have the input completely squared. So this implies that f of x should be just x squared. Or you can go with a dummy variable if you're confused with the x notation here. Take it as like f of u equals u squared. Okay, so that's awesome because now I can go back and I can write the value of this integral as f of g of x plus c, right? So now the question is like, who is capital F? Capital F should be the antiderivative of little f, okay? And little f is this function here, and its antiderivative, so let me just write in terms of u again. Its antiderivative is found by the power rule for integration. So it's going to be u cubed plus 3. Okay, so we're almost done. So I can go ahead and then say that this integral times 2x dx is equal to f of g of x plus c, and that's equal to x squared plus 1 quantity cubed divided by 3 plus c. Okay, so this integral, in other words, is x squared plus 1 cubed over 3. All right, before I finish the first part, you can also check this exercise after you're done with this video. I have two examples here. Cosine 4x multiplying 4 over x squared. So this is a good pattern recognition type integration. And here you have exponential of this big chunk of an exponent multiplying this polynomial. So I can tell you, I can give you the hint just to work on for now. Here, so you know that we're chasing like f of g of x times g prime of x. Here, for the first part, you can start calling g prime of x to be 4 over x squared. And then you can come up with what g could be, matching the description of cosine 4x. And for part B, again, we're chasing f of g of x times g prime of x, and g prime of x looks to be more like x to the 5th plus 1. And then you can sort of like imagine what the antiderivative of g could be, and that has something to do with the description of the exponential function over there. All right, that's a good exercise for you. Please do it. And this is the end of the first video. And then the next video is going to talk about, let me just quickly mention about that, change of variables to find an indefinite integral together with the generalized power rule for integration to come up with the values of indefinite integration. All right, see you in the next video.